Hey, how's it going, everybody? My name is Troy Hackett. I am the head TA for Managerial Accounting at Cornell University, more specifically for Professor Paz's class. And today we'll be looking at a CVP analysis question on one of the practice prelims, more specifically prelim number 1, or practice prelim number 1. A lot of words right there. So basically, this is one of the harder questions in my opinion, and you do need to utilize a couple of more algebraic strategies to solve this question towards the end, but we'll go over it and we'll discuss how to solve it. So Juliet's joint sells 2 types of dinners, chicken and jumbo. Juliet's dinners have the following selling prices and variable costs, right? So they give us a selling price, which is how much they're selling these meals for, and they're telling us the variable costs, how much it costs to make one of these dishes, or the variable costs associated with each dish. For example, for the chicken dish, it would be, the labor associated with creating that and perhaps the cost of buying the raw chicken. And they tell us that 60% of the meals sold are chicken and monthly fixed expenses are $22,000. And it says, given the sales mix, compute the weighted average unit contribution margin and weighted average contribution margin ratio. Okay, so weighted average unit contribution margin, basically we're finding the average between the 2 contribution margins and weighting them, right? Because it's not an even 50-50 split. Because 60% of the meals sold are chicken and 40% of the meals sold are jumbo, we gotta put a little bit more of the weight to chicken. So first of all, let's solve for the weighted average unit contribution margin. And to do that, what we're gonna wanna do is first find the contribution margin for chicken and for jumbo. For chicken, we're gonna do 20 minus 12, right? Because CM is revenue minus variable cost. We're gonna get $8. And for jumbo, so this is chicken CM. And for jumbo CM, it's gonna be 12 or 16 minus 6, and we're gonna get $10, right? And now to find the weighted average CM, we're gonna do $8 times 60%, or 0.6, because 60% of the meals sold are chicken, plus 10 times 0.4, right? And we're gonna get 8.8, okay? $8.8. So not too bad. And now we want to find the weighted average contribution margin ratio. So what we're going to want to do here is we're going to take the CMs of both, so $8 over 20. So 8 over 20 is how we would usually find, the CM ratio of one specific item, right? We take our CM and divide it by the revenue, which basically tells us here that if you divide 8 by 20, we get 40%, right? So for every dollar we make, 40 cents goes towards profit for the chicken meal. But here we want to find the weighted average contribution margin ratio. So we want to combine the chicken and the jumbo together and have them both weighted to make it accurate. So we're going to multiply this by 0.6 because the meal sold for chicken is 60% of the restaurant's business, and we're going to add 6 over 16 times 0.4. And we're going to get 39%, aka the 0.39 contribution margin ratio. And did I do something wrong? I might have. All right, so I did something wrong here. I don't know if you guys caught me, but this figure right here should be 10, right? Because it's our CM over our selling price, right? And what I did was variable cost over selling price, which is not the correct formula. So if I plug that in correct, I should get the correct answer, or if I plug it in again, and we get 49%, which is correct. So I'm gonna put in 49. So this is 49%. So for the next part, it says, given the sales mix, compute the total number of meals that Juliet must sell in a month to break even. And it says also identify total sales at break even. So at break even, you got to understand what break even means, right? So break even means if you take revenue minus variable costs minus fixed costs, you would have $0. Break even, right? You're not making a profit or a loss, you're simply breaking even. So right here, what I want to do is take that average contribution margin, so it's 8.8, times X, and X is what we're trying to solve, which is the total amount of meals minus 22,000, which is our fixed cost, and make it equal 0, right? Because 0 is break even. We're not making or we're not losing money here, right? So 8.8x equals 22,000. If we divide it here, 22,000 divided by 8.8, and we get 2,500, okay? So that basically means we gotta sell 2,500 units to break even. And it says also identify total sales at break even, right? We gotta identify how many sales we're making at break even. So what we wanna do here is we gotta find the average selling price, the weighted average selling price, and multiply it by 2,500, right? Because 2,500 is not just chicken or not just jumbo. It's a combination of both. So we're gonna do 20 times 0.6 plus 16 times 0.4. And from doing that, we are gonna get 18.4. Do that times 18.4. This is the average selling price, or weighted average selling price. And we're gonna get $46,000, okay? So if he makes $46,000, he's going to be making no money or make no losses by the end of the period. Now let's look at 5.3a. Suppose Juliet can only service 3,200 meals a month and wants profits of $8,800. If sales mix is the only controllable variable, what proportion of meals sold would need to be chicken? So basically the sales mix is the only controllable variable, which means that instead of chicken being 60% of meals and jumbo being 40% of the meals sold, we can change that up to make sure we have a profit of $8,800. And he can only service 3,200 meals a month. So I'm going to do 3,200 times X minus 22,000 equals 8,800, okay? So that might look a little bit confusing, but basically I'm multiplying 3,200 by X. And X is the weighted average selling price of, of the price we need to make a profit of $8,800. And once we find X, we can use another equation to find the percent which needs to be chicken, the percent which needs to be jumbo. And I'm kind of rambling here, so let's just get right into it. So 3,200X equals 30,800. X equals 9.625. So 9.625 is the weighted average contribution margin of chicken and jumbo. So what we can do here is we can put 9.625 equals, so we have our CMs here, right? 8 and 10, okay? So 8 times X plus 10 times 1 minus X, right? So to explain this, X is the percent meals which are sold as chicken, right? And this number is not gonna be 60% anymore. We have to change it up in order to meet our profit margins. We gotta make more, we gotta sell more jumbo meals compared to chicken meals because jumbo has a higher CM. We're making more money per meal sold. So if we, multiply this out, and just to clarify, we can basically use X twice because if you add the jumbo percent and the chicken percent together, they would become 100%, right? So that's why we can have X here and 1 minus X here. To multiply this out, we're gonna get 8X equals 10 minus 10X equals 9.625. And then this is gonna be an addition. This is an equals. And then we're running out of room, so I'm just gonna erase this later. But if we do, let's see here, 9.625 minus 10 equals negative 0.375 equals negative 2x, x equals, or 2x equals 0.375, x equals 18.75%, right? So that basically means to make this profit figure possible, we can only sell 18.75% of our meals sold have to be chicken. The other, 81.25% of meals have to be jumbo because jumbo has a higher CM, which will help raise those profits. And it says for the next part, it says suppose Juliet can only service 3,200 meals a month and wants profit of $8,800. If the sales price of chicken is the only controllable variable, what is the sales price for chicken that is needed to meet objective? So in this situation, he is unable to change the sales mix, right? We're unable to use that strategy where we sold more jumbo to help raise our profits. In this case, the only thing he can do is raise the price of chicken meals. Okay, so I was thinking about it for a bit, and as you can see, I wrote a little bit down here. So I basically wrote an equation saying 9.625 equals 0.6 times x plus 0.4 times 10. So I got the 9.625 from our previous question, which is the CM needed to make a profit of $8,800. But instead of, changing the 0.6 and the 0.4 in this case, I am making the CM of the chicken the X factor, because we don't know that figure currently because we need to change the price of the chicken to make more money. And there's a fly flying around me, which is super annoying, but let's just keep going. So if we multiply this out, we get 0.6x plus $4, which equals 9.625. We're gonna move that over. 5.625 equals 0.6x. We're gonna get 9.375. But remember, that is a CM, right? So we need to find the selling price. And to find a selling price, we would do CM plus variable cost to get the selling price, right? So the CM, or the variable cost, is $12. So we add that and we get 21.375. So basically we got to raise our chicken price by $1.37 in order to meet this profit target. So for the final part of this question, it says refer to original information. A tennis team comes in and can't decide between buying 16 chicken dinners or alternatively 14 jumbo dinners to share. Which selection should Juliet encourage? Explain with numbers. At first glance, you would say, hey, we should sell the chicken dinners, right? Because we're selling 16 instead of 14. If you're making the same amount of money per dish, that'd be correct. But however, we talked about earlier that jumbo actually makes more money per unit. They have a higher CM. So for every meal you're selling of jumbo, you are, contributing more dollars to profit than chicken. The chicken profit margins are slimmer. So if we do 16 times 8, which I believe is the CM, right? So we're taking the number of meals times CM, right? Because CM is what ultimately contributes to profit, right? It's taking into account variable costs. And what we get there is we're gonna get 128, I believe, off the top of my head. Yep, there we go. And if we do jumbo, 14 times 10, we get $140, right? So even though the chicken dinners, we can sell more of them because their profit margins are slimmer, it's actually it's better for the company to sell the jumbo dinners because they're higher, they have a higher CM, a higher profit margin, and we're making more money per meal sold. To clarify this and smash it out of the park, think, for example, selling Xboxes compared to Xbox controllers, right? Selling the actual Xbox console probably makes you more money than just selling the controller, right? If you sell the console, you're making probably $200 per console, and for the controller, you're only maybe making $20 per remote. Therefore, even though you have an option to sell more Xbox controllers, it would actually be more beneficial to sell less consoles instead because you're making more money per console. I hope that all makes sense, and if you have any questions, leave it down in the description. I know this one's a little bit more messy. This problem is a little bit more messy, and honestly, I've been recording these videos for 3 hours now, so I'm going a little bit crazy. But yeah, let me know if you have any questions in the comments. Thank you.